Guys, in case of synthesis of alcohol, we can also use carboxylic acids. Carboxylic acids are reduced with lithium aluminum hydride in aqueous acidic medium to give alcohol. Now, the problem with this process is lithium aluminum hydride is very expensive. So as a result, this becomes expensive process. So what we do is we treat carboxylic acid with alcohol to get ester first. So in step 1 we synthesize ester in acidic medium. Alright. So the reaction is carboxylic acid plus alcohol giving you ester and water as byproduct. OH and H as byproduct. Now the ester synthesized is then reduced with hydrogen gas in presence of nickel or palladium catalyst. On heating, what we end up is with two alcohols. One alcohol of this gets reduced RCH2OH. So this is one alcohol which we get, and this is yet another alcohol that we get. So we get RCH2OH plus R prime OH. Alright, so we are recovering this alcohol back. Alright, okay, now this process is fine. So now if you noticed, I have put here OH as red, and even in water I have put OH as red. So normally we have tendency to think that acid, this is carboxylic acid, would be contributing H towards formation of water, and alcohol would contribute OH to form water. Alright, but this isn't true. This would be proved by Fischer's mechanism for esterification. Alright, so let's get into it. In case of Fischer's esterification mechanism, what we do is we take acid, carboxylic acid, we treat it with alcohol, okay, and now R prime OH, RCOH reacted, obviously in presence of acid. Alright, and what we end up is with ester and water. Now let's understand the mechanism. We have got H plus over here. This is our acid, carboxylic acid. Now this is C double bond O. O, we always know that it has two lone pair of electrons, and so it's one of the best nucleophile anytime. Alright, so what it does is it does nucleophilic attack to proton present in the medium. As it does that nucleophilic attack, it forms a bond over here. Now when it forms a bond over here, what happens is oxygen has double bond and one more bond, so excess of bond, so it has plus charge on it. So to satisfy this plus charge, I already told you earlier that whenever there are two bonds, one is sigma strong bond and one is pi weak bond. So this bond shifts over oxygen to satisfy its positive charge. Alright, now when it does so, you get positive, carbon gets positive charge, it becomes a cation. So as it becomes cation, it becomes one of the best opportunity for alcohol to do nucleophilic attack on carbocation. Alright, why? Because as mentioned, oxygen has got two lone pairs, so it's one of the best nucleophiles, so it does attack on carbon, which gets positive charge owing to shifting of this pi bond on oxygen. Alright, so see, there was positive charge over here. This is quite satisfied now. There's no positive charge because it has been quenched by the pi bond over here. Now this thing has attacked, that is alcohol has done a nucleophilic attack, so it gets attached to it. But when alcohol does nucleophilic attack, now look out for oxygen. Oxygen has HR, one bond H, one bond R, and yet another bond, so oxygen gets positive charge. Now keep in mind, whenever there's an excess of bond in a molecule then required, the atom gets positive charge. So did it get it here? So did it get it here? Alright, so now what happens is this has to be neutralized, the positive charge. So H, which was there, the bond shifts towards oxygen. Alright, and this becomes proton. This becomes proton as H is stripped of the shared electron. So it is taken up by O plus. So now this becomes positive charge. So this becomes a proton. And this is satisfied. Alright, this is satisfied by, because 3 bonds were there, now it has got only 2 bonds. So O, C, O, R prime. So it has got 2 bonds, so no more charge over here, satisfied, but hydrogen has lost its electron pair, so it is proton. Alright, so in next stage what happens is, this again OH which is there, we are seeing there are 2 OHs there, and whenever any time if carbon has 2 hydroxys along with it, it's the most unstable state. This out of 2 OHs, 1 OH and 1 H would go out as water. So how does it go out? It needs 1 proton. So this proton, so already I mentioned here, this is the best nucleophile, so it does a nucleophilic attack on this proton. Okay, when it does nucleophilic attack on this proton, so this is what happens. So this H is this H and this H, a newly formed bond, and then what happens is this, now since again oxygen has got 3 bonds, so it gets positive charge, so the bond pair is shifted totally towards O plus to satisfy it and to form water. Alright, to form water. And when this shifts over here, carbon gets positive charge because this bond is no more there, right? So it gets positive charge because there is shortage of bond, positive charge. Now since it is positive charge, so this bond shifts over here to satisfy carbon, satisfy the positive charge. Alright, and satisfy also the tetravalency of carbon. So this bond when shifts over here, this is the new bond that it forms. Alright, now again the bond pair of H has shifted here, so this becomes proton, so that becomes this proton. Alright, so this forms double bond. OR prime already got attached, and this left out as water for satisfying O plus. The bond pair shifted towards O plus to satisfy this as water, so it got water and H plus. Mind you, we use catalyst. Now we use small quantity of say sulfuric acid as catalyst. Alright, acid. Now that is this. Now catalyst, we have learned that it takes part in reaction but is recovered again. So this H plus we found it took part in reaction, but this H plus is recovered back again, and that's how we explain catalyst. Alright, catalyst is one which takes part in reaction but is again recovered. So sulfuric acid which gave its proton got it back at end of the reaction, so now that sulfuric acid would be reused again and again in the reaction. Alright, so that's why it is a catalyst. Alright, this is the entire mechanism by which esterification occurs. Alright, now let's understand. And yet another thing, as I mentioned in my earlier video, we always felt that this H plus was one, this being an acid gives out H plus, and that H plus and this OH forms water. But this isn't true. So what is true? Truth is this OH and this H forms water. Alright, now this has been proved by O18 labeling. Alright, by using alcohol with O18 isotope. How? Let's understand. So isotopic labeling. So what happens in case of isotopic labeling is we take carboxylic acid and an alcohol in which oxygen is isotope, O18 isotope. We know oxygen exists in 3 isotopic form, O16, O17 and O18. So we are using here heavy oxygen, that is O18. Alright, now on doing this reaction, where in the product or bioproduct do we find presence of O18? Let's understand. Now what we find is that the ester has O18, whereas water does not have O18. Alright, so this is not what we observe experimentally. Alright, so this itself proves that where was O18? O18 was with alcohol. So this itself proves that contribution of H is from here and OH is from here. Alright, so we can write the reaction like this: RCOH plus R prime OH, where H and OH combines to form water as a byproduct, and this alkoxide and this part combines to form ester. Alright, so proving that its OH of carboxylic acid is involved in water formation and not H. Alright, so OH is involved and not H. So we always used to feel that it was the H from here and our OH from here to form water, but it's not true. This O exists in product. This entire part exists in product. So this O exists in product, whereas this OH doesn't exist in product, but it exists in byproduct. Alright.